Part 2 of this 2007 hybrid Ford Escape. What the compressor and the receiver dryer was replaced on. So now we have a system. We're taking our Bluetooth readings, live pressure sensor gauges, so we could record it as documentation. Here I'm hooked up to the liquid high line. This is two systems. Evaporator is in the rear for the battery, and I have right at the Y was the only place I could get the sensor to take the temperature of the refrigerant. Then I'm taking the temperature of the refrigerant just leaving the front evaporator, since the rear going to the battery turns off and on as needed. Inlet air temperature to the evaporator. I have the temperature sensor that's another 12 inches down there going down into the opening of the inlet right into the evaporator. So the temperature, the hot engine heat air coming from the engine, from the exhaust radiator, is being sucked down in through the corral right up there. It gets sucked down, it travels down, it goes inside to go to the evaporator, and that's the point where you want your mixed air temperature just before the evaporator. It's going in at 107 degrees right now. The pressure is 176 on the high side, 35 on the low side. Taking the low temperature sensor from here. We got 58 degrees coming out of the dash. As you can see, high load, all four doors open, rear hatch open. So having 58, 59 degrees coming out of the dash, at 107 degrees air going in, you got off the top of the head roughly 47 degrees or so temperature difference. So there's your temperature split of almost a 50-degree temperature split. The other scenario, close the doors, roll up the windows, put it on recycle to see what your minimum is capable of doing off a load, but just to check. So in this scenario, the high pressure drops down to 136, the low pressure goes down to 27 or 30, and the dash center duct temperature drops down to 40.3 degrees. Your superheat and subcooling are calculated by the math formula inside your app that will give you your printout for your customer. And then, as we always do, remember to shut off your valves, open up all your valves here, evacuate out your system. I'm down to 102 microns. Now I'll take my refrigerant charging hose, hook it up to the nitrogen, and put a slight positive charge to store my gauges to the next job I'm going to right now. So my hoses are dry and have a slight positive pressure, just in case anything unthreads, you don't suck in under vacuum wet air and saturate your rubber that'll absorb moisture. You have a slight lining of residue oil inside, your PEG oil, ester oil. This set of gauges with this set of hoses gets used with ester. I have another one for PEGs, my old mineral system for R12 and R22. Different set of gauges with a different set of hoses for different refrigerants and different types of oil. And that's it for now on this one. Later I'll get into how to diagnose dual AC systems so you can diagnose the rear expansion valve or orifice tubes, especially when they have a solenoid that under certain circumstances literally closes off the flow of refrigerant, and if you don't know what you're doing, you can have a really big problem trying to draw a vacuum or charging the system.